So if I have a trinomial I want to factor, one thing I can do is try the x box like the last video you watched. But sometimes there are even more special trinomials called perfect square trinomials. So first I just want to give you an example of what a perfect square trinomial would factor to so we can see what the structure looks like. You don't need to write this problem. So a perfect square trinomial comes from when I have something like 2x minus 3y squared. If you remember, when I square something, that's the same thing as multiplying it to itself 2 times. And if I FOIL or use the box with this, we can multiply it out. You know which one I like. So I get 4x squared, negative 6xy, negative 6xy, positive 9y squared, and when I combine like terms I get 4x squared minus 12xy plus 9y squared. So what kind of numbers do I begin and end with? I have positive numbers and they're both perfect squares. Okay, so that's the first thing I look for. Well, first is that it's a trinomial. Second, that I begin and end with positive perfect squares. And my last condition has to do with this middle term. If you notice, this middle term came from multiplying the 3y times the 2x, and I did that twice. So you have the same thing on the diagonal of your box in this case. So we're going to write that formally on the next. So my first condition is obviously for a perfect square trinomial, which I abbreviate a lot of times as PST because perfect square trinomial takes too long, is we need a trinomial, so 3 terms. I need to, my first and last term are positive perfect squares. And my last one is kind of hard to say. So if I want it to be able to write it like this, then my middle term is 2ab. aka, when I check this diagonal right here, then it's going to add up to 2ab. This is another one of the many reasons why I like the area model, because what am I trying to do with the perfect square trinomial? I'm literally trying to make the sides a square. So let's look at some examples. In these examples, we're saying, are these perfect square trinomials or not? So the first thing I do is, all of these are trinomials, so we're good to go for that one. Does this begin and end with positive perfect squares? Remember, perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, etc. So yes, I begin and end with perfect squares. So what we want to do is put this in our box, because the other question is, if it's yes, then we are going to factor it. So first term, first box, last term, last box. And now, since we're trying to make this a perfect square trinomial, and only because of that, we're going to split this middle term in half. So half of positive 10x, or sorry, positive 20x would be positive 10x. And now we factor it out like the other video. So GCF 2x, 2x, positive 5, yay, it works. So I can write this as 2x plus 5 squared. So yes, it is a perfect square trinomial, and it factors to 2x plus 5. If I look at example 2, do I begin and end with positive perfect squares? No. So not a perfect square trinomial. It doesn't, if it's not a perfect square trinomial, it doesn't necessarily mean it doesn't factor. This one doesn't, but sometimes they do factor. It just means it's not a perfect square trinomial. Okay, so looking at the next one, do I begin and end with positive perfect squares? Yes. So let's try. X squared, first term, first box, last term, last box. And let's try splitting that in half. If I split positive 12x in half, I get 6x, 6x. And if I think about the sides, is that going to give me 144? No, so not a perfect square trinomial, because my middle term is not working out and multiplying to what I need it to. Okay, last example right here. First and last are positive perfect squares, so let's try. First term, first box. Last term, last box. We try to split our middle term in half, which would be negative 5x, negative 5x. So x, negative 5, negative 5. Does that work with my last box? Yes. So this would factor to x minus 5 squared. So if you think you're getting the hang of it, I want you to press pause and try the next 6 examples. Hint, all of these are perfect square trinomials. So they begin and end in positive perfect squares, and if we do it correctly, they should work out. So first term, first box, x squared. Last term, last box, 81. Let's try splitting in half. 9x, 9x. Factor it out. X, 9, 9. So x plus 9 quantity squared. You may think this seems kind of silly right now, but we're going to get into something called completing the square, and that becomes really important as we go through the course. So this does actually end up mattering. Okay, first term, first box, last term, last box. Try splitting in half. So 7a squared, 7a squared. Now walk it out, now walk it out. There we go. A squared, 7. 7. So a squared plus 7 quantity squared. First term, first box. Last term, last box. And then let's split our middle term in half. Remember, we're splitting it in half because we're trying to make a square. Okay? So square needs to have the same sides. So 5x, 5x, negative 7, negative 7. So 5x minus 7 squared. Now we start getting a lot more variables going on, but we do things the same way. First term, first box, last term, last box. We also want to make sure our stuff is working with my variables. Like I said, all of these ones were going to work, but sometimes I'll give you, are they perfect squares trinomials, yes or no? And so they may not be. So be careful with your variables. So 4x, 5y, 5y. So 4x plus 5y squared. Notice that, by the way, if I had a minus as my middle term, it's a minus in my factoring, plus, 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 plus. So that's where that sign is coming from, is from your middle term. Last two. So x squared, 16, split my middle in half, so that'd be negative 4x, which would be x, negative 4, x minus 4 squared. Now, an example that starts off looking kind of the same would be this. So if I tried that, begin and end in perfect squares, that's not on your paper. So I might try it. If I split that in half, when I try to take that out, I'm going to get negative 5 and negative 5, which is definitely not going to be 16. But if I do normal x box, I'll get what multiplies to negative or positive 16 and adds to negative 10, and I'll get negative 8, negative 2, and it's going to work with x box and factor to x minus 2, x minus 8. So it's not necessarily that it doesn't factor if it's not a perfect square trinomial. It's just not that situation. And last one. You can see my boxes are really a thing of glory. They're just so beautiful. Look at that x, you're jealous. All right. So negative 30x, and that would be 5x, negative 6, so 5x minus 6 quantity squared.